Hello, student. Precalculus, Chapter 1, Section 9. Inverse of a function. Inverse, the simplest way to understand it, it's not exactly the same way, is that if I have y equal x, let's use the simple fx equal x, then the inverse, -1 here on top mean inverse, equal 1 over x. So such way, kind of like a flip-flop, but that's kind of simplest way. But we have more thing we need to understand about inverse. We'll see some example. So if I have a function of x equal x plus 4, x plus 4, and I have a set of data a equal 1, 2, 3, 4. This is the input for x. If I plug here in 1, 4 plus 1 is 5. So this is the output or the range. So if I put 2, you're going to get 6. If I put 3, I'm going to get 7. If I put 4, I'm going to get 8. That's normal. So now we get set of pair input, output, input, output, input, output. Now, what is the property of the inverse? So here they're going to give us really the inverse. X minus 4. So the inverse of that function is x minus 4. Now we're going to notice something. Input is b. 5, 6, 7, 8. So we inverted that the input here is the b. So this was an output for the a. Now let's see what happens if we plug in 5 in here. 5 minus 4 is 1. If you put 6, 6 minus 4 is 2. You put 7, what's the output? 7 minus 4 is 3. If you get 8, 8 minus 4 is 4. Well, what is that? That the input A for this one. So here we have output. Output. So that is the property of the inverse. The original function input output, the inverse will use the output to be input. Then we get the input. We got the output to be the same as an input. That is the property of the inverse. They show us here a sketch, domain, which is mean input. The domain, this is x. You say x plus 4, you get the range, which is output. Now what's going to happen? This is the domain for this function. So this here, domain of this function or the input. Then we got back the output. Another important thing about the inverse if we do composition, F composition of the inverse like we saw before, well, let's write here's a function, fx equal x plus 4, inverse is x minus 4. Now to do the composition, F, let's write it down here, F composition inverse of x, that means we're going to take, this is equal here. Let me write this to look better. And fx inverse equal. Now I'm going to take all of this and plug it into this x. So we're going to get x minus 4 a plus 4. Well, 4 minus 4 is 0. What we left up with is x. Now if we have to do f inverse composition with the fx, we're going to take this here and put it into this x here. So basically, we're going to have x plus 4 minus 4. Well, 4 minus 4 is 0. The answer is x. Now, if I give you two functions, fx and g of x, prove they are inverse of each other. So basically what we have to do, we need to do the composition issue and get the answer equal x. So do f composition with gx, and this is must equal x. If I do g composition with fx, this is also must equal x. If this happens, then they are inverse of each other. So that was showing us here. And this is a condition to have an inverse. Also, if we know the inverse, then same thing. F composition with the inverse must be x, or inverse composition with the F must be x. Okay. Let's take an example. Fx equals 3 minus 4x. Let me get something else. Oh, that's fine. 3 minus 4x and g of x equal 3 minus x over 4. 3 minus x over 4. Are they inverse of each other? Of each other. Well, all we have to do the composition. F composition gx equal 3 minus 4. This x now here, this x will be replaced by the entire g of x. 3 minus x over 4. Let's simplify it. 3 minus, we have the, well, if you notice here, we have 4 here and 4 at the bottom. They cancel each other. Then we have 3 minus x. Move the negative to inside. Three minus 3, negative is positive x. Don't forget those parentheses, please, guys. But otherwise, we'll do mistake. Now, 3 minus 3 is 0, x. Okay, we got the first one to be correct. Let's try it backward. G composition was fx. Equal. Remember the composition being explained also in chapter 8 and section 8. So what is going to do? We're going to have a 3 minus over 4 minus what? Minus x. What is x? Is going to be the entire value from here. That's 3 minus 4x. Let's simplify it. We move the negative to inside. 3 minus 3 plus 4x over 4. Well, 3 minus 3 is 0. Then we get 4x over 4. Then this is also equal x by canceling the 4. Well, okay. Then you must say again, yes, they are inverse. Yes, they are inverse. Of each other. So this way we answered the question completely. Okay. Graph of the inverse function. Well, what they are telling us about the inverse function, if I have this gray shaded function, if I use the line y equal x, the dotted line, this is the y equal x. This is the mirror. Mirror. So, and this is reflection. Reflection of the other one. That's why we call them inverse. Here we have another example. If this is 2x minus 3, and this is the inverse. To prove that this is the inverse, we can still make the composition fx, f F inverse of X, composition with the inverse. That means we're going to say 2, open parentheses, you have 2, you have X plus 3 over 2. Half, that means you can put it over 2 like that. This is the same thing. Half or X plus 3 over 2 is the same thing. This is minus 3. So we replace this X by the entire value from here and simplify it. 2 and 2 cancel out. You get X plus 3 minus 3, that equal X. That's correct. That's what we have to say. Same thing if I want to do F inverse of Fx, composition with Fx. Let's see what happened. We're going to replace this X with the entire value from there. So let's put 2 under. Then use 2x minus 3. That's the entire thing. We put it in this X. Then a plus 3. Well, 3 and 3 is gone. You get 2x over X over 2. Then 2 cancel out. All right, they are inverse of each other. That's correct, they are inverse. They didn't lie. One-to-one function, horizontal line test. So really, is not every function has an inverse. Some functions they do, some functions they do not have an inverse. How would we know that? They said, if I have horizontal line, let's say you have a function first, I should be able to take horizontal line and sweep it up and down. I must always have one point of intercept, only one point of intercept, then the function has an inverse. So this has an inverse. Okay. Then if not, what's happened if it not? If I have the function like this, then if I run my horizontal line, I have two. So this is an x squared. So this function, fx equal x squared, or anything have an x squared in it, has no inverse. Okay, so this one has no inverse. A line always have an inverse, because when you sweep your horizontal line, you get only one point of inverse. Yeah, no inverse. Finding the inverse, that's the big issue. How do we find the inverse? I'm going to solve an example, and I'm going to show you step by step how to do it. You follow these steps, you are in good shape. 5. So this is the function. Find the inverse of this function. Okay. To find the inverse of this function, we're going to do the following. Your first step. Well, let's write the first step here, because we need more room. Rename fx equal y. So y equal 5 for convenient. All right. Second step. Second step, exchange names between X and Y. Exchange names between X and Y. So basically X become Y and Y become X. X equal 5 minus Y over 3X plus 2. Oh, 3Y plus 2, I'm sorry. We should not do this mistake. So everything here become Y, and now third step, cross product. Because this is going to have a bottom one. Let's rewrite it. Product or multiplication. So what's going to happen? You're going to have X multiplied by 3Y plus 2 equal 5 minus Y. Okay. Move the X to inside. What are you going to get? Simplify or distribute X. Force. Shoot X. You're going to get 3xy plus 2x, because multiply x times 3, 3y, 2x, that's equal to 5 minus y. Fifth step, isolate y. Move all y to left, everything else to right. Thing else to right. So this has a y, I'll leave it, 3xy. Then I'll move the negative y to the other side, become positive, plus y equal negative 2x plus 5. If I move the 2x to the other side, become negative 6. Factor out y. We're going to get y 3x plus 1. It's not 0, plus 1. When you move this y out, become 1. Equal negative 2x plus 5. Now divide both sides by 3x plus 1. And y is equal negative 2x plus 5 over 3x plus 1. 7ths. Rename y equal f inverse x. So the f inverse of x equal negative x plus 2x over plus 5 over 3x plus 1. Guys, this is, you do not stop at the y. You must tell me this is the inverse, because as you must do all of these steps, 7 steps. when you do it a written test. Okay, I think let's see what's left. So let's look. Also, is in the book, they have it written in a good way. They show you also the same steps. So section 9 is finished. Also, chapter 1 is finished, is over. So let's see what practice you can do. Okay, practice 1.7. If you look it out, please practice this for your own benefit. And first question is prove inverse of each other's. We did the example and find the inverse of this function. So we already solved 2 examples, just follow the process exactly, and you get it done. All right. I'll see you next time in chapter 2.